talk about before we get into our textbook is if I have a shape that starts in quadrant, let's say 2, so where this purple one is, and I rotate it 180 degrees clockwise, what quadrant will it end up in? I'm starting with, raise your hand, the purple one. I'm rotating it 180 degrees clockwise. Where will it end up? Brianna? Quadrant 4, so where the red one is, right? Because this would be 90 degrees, 180. If I start in quadrant 3, so the green one, and I rotate it 90 degrees counterclockwise, where will I end up? Starting here, rotate it 90 degrees counterclockwise, what one will it end up? Grace? Quadrant 2, because I would go backwards 1, so where the purple one is. If I start in quadrant 4, so the red one, and I go 90 degrees clockwise, where will I end up? The red one, 90 degrees clockwise, where will I end up? Aubrey? Clockwise. 3. Good. So where the green one is. If I wanted to go counterclockwise, I would end up where the yellow one was. Okay? So it's good to know our directions, which kind of talks about what our first thing is on our bell work. So in your own words, if you're spinning it clockwise, which direction do you go, DJ? Right. Good. And I'm not sure why it's not writing. Right. And if I go counterclockwise, which direction will it go? Josie? Left. Good. So this would be right, this would be left. If the section 8 labeled on part of the wheel spins 90 degrees clockwise, where will it land? So this is 8 down here. And I spin it 90 degrees clockwise, where would I land? What number? Carter? I believe it is. Oh, it doesn't have a number, I guess. What position of the wheel would I land? Top, bottom, left, right. I'd land up at the top, right up here. So, top. One of the sections labeled 4 makes 3 complete clockwise or counterclockwise turns. How many degrees will it have traveled? So what would one full spin measure? 360. Now if I do it 3 times, what would I do?
1,080.
I'd multiply by 3, and I would get 1,080. Because if I make 3 complete turns, I'm going 360, 360, 360. Are there any points on the wheel that stay fixed or do not move when you spin the wheel? So are there any of the points on that entire wheel that when I spin it, it won't change? The center. Because this point right here will never change because it's going around that. What point on our coordinate grid would that be?
0,
0, 0, or it's also called the origin. Perfect. Does the center of the wheel change if the wheel is spun counterclockwise opposed to clockwise? No. Does the distance from the center to the edge change as it's spun? No, it is a circle. So does my shape change size? No. Does my shape change shape? No. Does my shape change direction? Yes. Because if I spin it, my 8's going to land over there. Okay, if I spin it the other way, my 8 will land over there. So we keep the same size and the same shape, but the direction changes. Okay? What is it called on a circle from here to here? That diameter is the full length.
That's the base.
The half of it is the radius. So the way that the book explained it is that the radius doesn't change on the circle as you spin it. Okay? Let's go to the next page. I'm going to skip example 1. I want to go to example 2, so 477. This kind of talks about rotating around the origin like we already have. So A never changes its distance from 0. It just moves around the origin. Okay, it moves around the 0. It also gives us our rules that we can use. So let's go ahead and turn to the next page. We're going to look at Got It B. It says to graph the original, so let's go ahead and graph the original. So 2, 5, 6, 4, 6, 1, and 2, 1. Your shape should look like mine when you get done. Anybody got any questions on that part? Okay, go to the next page. Okay, it says that we are rotating it counterclockwise. So am I going to go right or left? Left, because I'm going counterclockwise. Now I'm going 270. So how many quadrants will I move?
3.
3, right? Because this would be 90, 180, 270. Okay? So I will be in what quadrant? Quadrant 4. Okay, so if I graph them, anybody remember what the rule was for 270 counterclockwise? Same X, different Y. Let's double check. We're going 270 counterclockwise, right? So it's Y, comma, negative X. What? 90 degrees clockwise is the same as 270 counterclockwise, right?
Yeah.
And we're going counterclockwise, correct? Yeah. So it should be Y, negative X. So what was M's original Y? 5, comma, opposite X. Negative 2. Let's graph that. So over 5, down 2, that should be M. N, what's its Y? Or N's original Y is 4, comma, opposite X. P, Y would be Y would be 1, opposite X. I forgot to graph N. 1, 2, 3, 4, 5, 6. This is N. P is 1, 6. And Q should be Y is 1, comma, opposite X. So then I'd go over 1, down 1, 2. Do I have the same size?
No.
Yes. Do I have the same shape?
No.
Yes.
Yes.
Yes, you rotated it. It's just facing a different direction. They're both trapezoids. Okay? You rotated it 270 counterclockwise. Questions on this? It is different, but you're going to have to use the rules. And we'll make some note cards with that tomorrow. Okay? I do have an exit ticket for you. So you your you might want your Chromebook out so you can use your notes for it. When I hand you a note card, please put your name at the top. Okay, put your names on it. I'm going to have, I think I have 2 questions. All right, so your exit ticket's up here. If the pre-image is located in the first quadrant and rotated clockwise 90 degrees, what quadrant is the image in after rotation? Number 2, if a pre-image is located in the third quadrant and rotated counterclockwise 270 degrees, what quadrant is the image in after rotation? I'm going to add another one. It's up here on the board. If you need to move, you can. Again, if you want to use your notes, you can.